leaders, scholars. My name is Jie Yang. I'm from China National Petroleum Company. And my item is the application of absorption, calculation, percolation, ultrafiltration, also hydrogen peroxidation, distillation process for produced water discharge. My presentation contains 4 parts. The first part is the introduction. China has the largest recoverable shale gas resource. Clean production is the most important mode. More specifically, China plans to achieve shale gas production of 80 to 100 billion cubic meter by 2030. And Sichuan Basin is the largest shale gas play in China. It plans to achieve shale gas production of 25 billion cubic meter by 2025, 40 billion cubic meter by 2030. And President Xi says green mountains and lucid waters are indeed mountains of gold and silver. So clean production is the most important mode. That means we should produce the shale gas without any pollution. The produced water was generated as gas lift with forming agents was used. Discharging is a necessary choice for produced water due to no or a few demands for reuse. The produced water was generated as gas lift and forming agents were adopted to stream water out of this is the form agents. Then put the form agents into the well and forming producing the forming will take stream water out of the well to optimize the well at the middle and the later stages of shale gas production. At the early stage of the shale gas production, it will produce the flowback water. Due to no or a few demands of treated water for use, and based on national and local laws and regulations, discharging after treatment is a necessary choice for produced water. We use the common technology such as the calculation, percolation, filtration, distillation process to treat produced water for discharge became more difficult. We can see from the table the quality of effluents after compound treatment. The COD of the effluent treated by coagulation, flocculation, ultrafiltration, distillation process is more than 100, and the concentrate of the ammonium nitrogen is more than 40. And as we can see from the quality of crystalline salt, the quality of crystal salt treated by the common technology cannot meet the requirements for reutilization. So the distilled condensate and crystal salt cannot meet the standard. So we need to solve this problem. As we know, the calculation, flocculation, oxidation, absorption, filtration were reported to be effective to remove COD and ammonium nitrogen. So we studied systematically these technologies to remove the COD and ammonium nitrogen. The part 2 is the materials and the method. The produced water sample was obtained from the reservoirs in Changning shale gas play of Sichuan in China. This is the national shale gas play. We studied the PSA, PM, or solvents such as coconut shale, clay quartz, activated carbon resin, and oxidizing agents such as hydrogen peroxide. And the methods, we studied the coagulation, flocculation process, oxidation, and absorption, coagulation, flocculation process, and also filtration and pretreatment and oxidization and distillation. In the calculation purification process, different dosages of PSA were added into produced water and precipitation. The supernattants were analyzed to confirm the optimal PSA dosage. And then the optimal dosage of PSA was added into produced water, followed by addition of different dosage of PAM. Then the supernatants were added to confirm the optimal PAM dosage. During the oxidization, the optimal flow rate, reaction time, and initial pH of ozone were conducted to confirm the optimal ozonation condition. Similarly, the dosage and reaction time, initial pH of hydrogen peroxide were conducted to confirm the optimal hydrogen peroxide oxidation condition. In the absorption calculation flocculation process and precipitation, the adsorbent was added into produced water, and the optimal calculation flocculation process was conducted to confirm the optimal type and dosages of adsorbent. Dead-end filtration cell in constant pressure mode was conducted to confirm the effect of ultrafiltration. The scheme diagram of ultrafiltration system is shown in the figure. And the fourth method is pretreatment oxidation distillation. The adsorption calculation flocculation ozone hydrogen peroxide distillation process under the optimal condition was conducted to confirm the quality of effluent and crystalline salt. Part 3 is the results and discussion. From the table, we can see the characteristics of produced water. The COD, ammonium nitrogen, TSS, and turbidity of produced water were much higher than that of flowback water. Specifically, the COD and the TSS of produced water was more than 10 times of that of flowback water. The ammonium nitrogen was several times of that of flowback water, and the total dissolved solids of produced water was comparable with that of flowback water. The results indicate that the water quality of produced water is much more complex than that of flowback water. So using the compound technology to treat the produced water to discharge is difficult. We start the calculation flocculation process to remove COD and ammonium nitrogen. The results of the process show that with increased dosage of PAC and PEM, the COD and ammonium nitrogen removal increased first and then decreased. The optimal condition is the PSA is 400 milligram per liter. The PM is 1 milligram per liter. Then the removal of COD is about 10%, and the removal of ammonium nitrogen is around 15%. The results indicate that the calculation flocculation process had little effect on removal of COD and ammonium nitrogen, which is very different from the repetition. And then we studied the absorption calculation flocculation process and the substitution. The results showed that only addition of clay removed the COD obviously, but had little effect on ammonium nitrogen removal. With increase of dosage of clay, the COD removal first increased sharply and then slightly. Then we get the optimal condition. The best adsorbent is clay. The clay is 20 gram per liter. Then the removal of COD is up to 76%. But the removal of ammonium nitrogen is only 28%. So so in order to remove the COD, we can we can use the clay to remove the COD. About the results, we should continue to study the effective technology to remove the ammonium nitrogen. The advanced treatment is another choice. The results of ozonation shows that with increase of flow rate and the reaction time, the COD and ammonium nitrogen removal first increased sharply and then slightly. The COD and the ammonium nitrogen removal increased first and then decreased in adverse with increase of pH ozonation, resulted in efficient removal of ammonium nitrogen rather than COD. So we get the optimal condition. The flow rate of ozonation is 0.75 liter per minute. The pH is 9 and the reaction time is 30 minutes. Then the removal of ammonium nitrogen can be more than 99%. Similarly, the the hydrogen peroxide oxidation, the results show that with increase of H2O2 dosage and the reaction time, the COD and ammonium nitrogen removal first increased sharply and then slightly. The COD and ammonium nitrogen removal increased first and decreased in adverse with increase of pH. Then we can demonstrate that the H2O2 oxidation resulted in efficient removal of ammonium nitrogen rather than COD. The optimal condition is the dosage of H2O2 is 200 milligram per liter. The pH is 9 and the reaction time is 60 minutes. Then the removal of ammonium nitrogen is more than 99%. So from the results above, we can conclude that the absorption is effective to remove the COD, and the oxidation is effective to remove the ammonium nitrogen. So we should combine these two technologies to effectively remove COD and ammonium nitrogen in order to discharge the produced water. By the way, the mechanism of the oxidation and precipitation is shown in my paper provided to the organization, conference organization. So we studied the effect of pretreatments, advanced treatments, distillation process on COD and ammonium nitrogen removal. The results show that this process can remove 90% of COD and 99.9% of ammonium nitrogen. The COD and ammonium nitrogen of effluent treated by the process can meet the national and local standards for discharge. The crystalline salt can meet the national standard for reutilization. We can see from the table the quality or the COD of the effluent treated by the process is less than 30 milligram per liter, which can meet the class first of GB, the national standard, and the ammonium nitrogen is less than 1 milligram per liter, which is much lower than the standard, the concentration of the standard. The quality of crystal salt is superb as well. And we have already used this technology in our engineering application. The left picture is the national Changning shale gas companies produce water discharging plant. The ability of this plant is 1,500 cubic meter per day, and the cost of the discharging is 25 to 38 euros per cubic meter. This is the right picture is the image of the produced water. The left one is the produced water, and the right one is the condensate. The crystal salt is super as well, pretty white. The part 4 is our conclusion and future work. Firstly, the COD and ammonium nitrogen TSS and the turbidity of produced water were much higher than that of backwater. Secondly, adsorption by clay is favorable for the removal of COD instead of ammonium nitrogen, while oxidization can obviously remove ammonium nitrogen but had limited effect on COD removal. Thirdly, the COD and ammonium nitrogen of effluent treated by adsorption, coagulation, flocculation, ultrafiltration, ozone, hydrogen peroxide distillation process can meet the national and local standards for discharge, and the crystalline salt quality can meet the requirements of industrial salt for reutilization. Lastly, the processing cost in the treatment of produced water should be reduced. That's all. Thanks.